this is your standard Bluetooth standard. Okay, so Bluetooth, again, it is of there are two architectures that are followed in Bluetooth. The first architecture is known as Piconets. I'll just start with it. So Bluetooth is again a wireless technology that you may have heard about. So it's one of the most popular technology. So it was invented in 1994 by, I think, Ericsson. Okay, so it is written here, Ericsson. Okay, so actually it is referred to as a wireless PAN. PAN means a personal area network because the range of Bluetooth is very small. Okay, so it is not a very long range device. Nowadays, Bluetooth has a range of like 200 or 400 meters up to. But when it is invented, the range was only like 5 to 10 meters. Okay, it is not more than that. Okay, so that is why it is referred to as a personal area device, a personal area network. Okay, so if you remember in like 2000 and 2004 5 in 2010, you use Bluetooth to transfer your songs to your friends. So that is why it is called a personal, because if you are not in the range, you will not be able to connect to a particular person. Okay, so you also have uh, if you if you I think you are not from that time, I think. So you will not be able to know that the pain of getting the one song transfer in like 5-10 minutes, and after that you cannot one Bluetooth cannot support two or more devices, so you only the connection was always one to one. Okay, so at the same time the devices were connected, but actually you cannot able to transfer anything. If you are connected to one devices and you're transferring one particular packet to a particular device, you will not be able to transfer any other a packet to, because the communication is like half duplex. Okay, either the sender can transfer or the receiver can transfer initially when it was invented. Okay, so it operated in an unlicensed industrial, scientific and medical band at 2.4 to 2.485 gigahertz. Okay, so you've seen this is the same range of the Wi-Fi network as well. Okay, so if you're watching a movie on a smart TV with a Wi-Fi network, with your Wi-Fi connected, when you connect your Bluetooth headset, what happens is that if your router is not dual band. Okay, dual band means it operates on 2.4 gigahertz as well as it operates on 5 gigahertz. Okay, so if it is not a dual band router, what it does is that your internet speed may be a little bit lower when you connect it to the uh, you connect it to the you connect it via your Bluetooth headset. Why it is so? Because your Wi-Fi as well as your Bluetooth operate on the same range. Okay, so the Wi-Fi range is also 2.4 gigahertz to something, and the Bluetooth range is also in this particular. So there is an interference when you connect to Bluetooth. So that is why your speed lowers. But if you have a dual band router, what it happens is that when Bluetooth is connected, so with the help of a dual band router, your connection just shifted to 5 gigahertz frequency. So that is why there will be your connection will be seamless when you are connected to a Bluetooth. Okay, so maximum devices that can be connected at the same time are 7. Again, you can connect with the another devices, but again the communication between them is one to one. Okay, so if you are sending some packets to a particular device, you will not be able to send the packet at the same time to another device. Okay, so Bluetooth ranges up to 100 meters. It provide data up to 1 Mbps and 3 Mbps depending upon the version. So nowadays, the Bluetooth version is quite advanced. Bluetooth 4.0, 5.0. Now it is in it is in Mbps and Gbps. Okay, so the spreading technique. Okay, so it is again frequency hopping spread spectrum. Again, it's a technique that if you read about some frequency techniques like Manchester encoding. Again, it's one encoding technique that is used in Bluetooth. Okay, so Bluetooth is network is called a Piconet. Okay, so it is following two architecture. First is a Bluetooth network is called a Piconet, and a collection of interconnected Piconets is called a scatternet. Okay, so there are two types of architecture Bluetooth follows. First is a Piconet and second is a scatternet. Okay, so I'll tell you about it, don't worry. Okay, so in Piconet there is one primary device and other secondary device. Okay, so I have a diagram. I don't think I have a diagram. Okay, so I'll show you diagram. Okay, so for only example of Piconet. Okay, so what happens is that in this particular Piconet there is one primary device and others that are connected to it are referred to as a secondary device. Okay, so this type of arrangement is referred to as a Piconet. So that is why it is also referred to as a Bluetooth network. Okay. Okay. So a Piconet can have up to 8 stations. So one of them is called the primary, another rest of all called the secondary one. So all the secondary stations synchronize their clocks. These are the secondary stations. They synchronize their clocks and hopping sequence with the primary. Okay. So if you want to transfer some data to any of these devices, so they will synchronize it with the primary and they will be ready for receiving the data. Okay. Another is your scatternet. Okay, so scatternet is I can call it, it's a combination of Piconets here. Okay, so if you're seeing here, this is an example of a scatternet. Okay, so this is a Piconet where one primary is connected to various secondary devices, and this is again a second Piconet when primary is connected to various secondary devices. And if you see that if I combine these two Piconets, it is referred to as a scatternet. Okay, so keep in mind when I'm taking the definition of a scatternet, it should be more than one Piconet. Okay, so if there is single Piconet, the network will be, the architecture will be only called a Piconet. But if there is more than one Piconet, you can call it a scatternet. Okay, so again, that definition is given here. Piconet is a type of Bluetooth network that contains one primary node called the master node and 7 other secondary nodes. Okay, so you can call it primary or secondary. Again, master and slave node is another name for primary library. Okay, so thus we can say that there are a total of 8 active devices which are present up to a distance of 10 meters. Okay, so this is the basic definition of Piconet, and the communication between the primary and secondary node is one to one or one to many. Possible connection is only between master and slave. Okay, so when slave connection is not possible, keep in mind. So in a Piconet, you will only be able to transfer from this particular device to this particular device. This particular device cannot transfer to any of this device. Okay, so it also have the park nodes. Okay, so park node is again one of the secondary nodes, but they are not at use. Okay, so what is the park node here means that they are ready for connection, but they will be part of the Piconet when one slave leaves. Okay, suppose this is your simple Piconet here. There are 1, 2, and 3 devices here. So one here is referred to as a park node. Okay, so suppose fourth node is referred to as a park node, but it is not a part of this Piconet. Okay, so it will become a part of this Piconet if this particular connection disconnect. It will come towards this and connect to this Piconet. Okay, so it is parked, but it is not in use. Okay, so when one slot is opened, it will directly connect to it. Okay, so that is the meaning of this park node. Okay, so it also have 255 park nodes. Those are secondary nodes and cannot take participation in the communication until it get converted to the active state. Okay, so they cannot. So the maximum you can in a Piconet maximum there are total 8 active devices, 8 active nodes that you may call it, but there are 255 park nodes. Okay, so it means that they are actually they are not in the active state, but they are there. Okay, so when one slot opens, park node can be changed, the status of the park node can be changed to active, and they will be able to communicate. Okay, keep in mind the park node are again secondary nodes. Okay, they are there will always be one primary and other secondary. Okay, so again keep in mind when you are talking about scatternet. Okay, so it can also happen that one primary node in one particular Piconet can act as a secondary node to other Piconet. Okay, so I'll take example, like I say that this is my primary, this is my secondary, this is my secondary, this is my secondary, and I could call this as secondary as well as primary. So why? Suppose it's a Piconet now. So again I'll take one more thing. One is this is secondary now and this is secondary now, and it is connected to this one. Okay, so when I'm talking about Piconet 1, so suppose this is my Piconet 1. When I'm talking about this Piconet, in this particular case, this particular node, that is node 4, is acting as a secondary node. Okay, so but when I'm talking about this Piconet 2, this particular node that is acting as a secondary in Piconet 1 will act as a primary in Piconet 2. Okay, so keep that in mind. It can also happen in a scatter net. It can also happen in a scatter net that one node can behave as a secondary in one Piconet and can behave as a primary in another Piconet. So that is one scenario that you have to keep in mind. Okay, so again, the scatter net is it's formed by using various Piconets here. A slave that is present in one Piconet can act as a master. Okay, so this is the one thing that I want to say. Okay, in scatter net. This kind of node can receive message from the master in one Piconet and deliver the message to its slave into the other Piconet where it is acting as a slave. Okay, so this node, this particular type of node is referred to as a bridge node. Okay, so because it is acting as a bridge between two Piconets. Okay, the station cannot be master in two Piconets. Keep in mind, in one Piconet, only one will be a master. That is the definition of a Piconet. That when you're defining a Piconet, it means that there will be one master and others are like a slave. Okay, so again, the Bluetooth protocol stack is based like this. Okay, so in this particular stack you will see that there are many layers. That this is the logical link control and adaptation control. So if you have seen the OSI reference model, if you have seen the OSI reference model, the TCP IP model, this particular model is totally different from that. Okay, so because if you're seeing here the functions that are repeated, that are there in already defined architectures, there are layered architectures, you can also use it as it is. Okay, so the link layer, if you are seeing here, it is equivalent to the data link layer. Okay, so more specifically it is equal to logical link layer. Okay, so because you know that logical link control, LLC. Okay, so the data link layer is divided into two parts. If you remember, this particular logical link control will act in data link layer. It is L2 cap is again equivalent to data link layer, whatever the functionality of a data link layer. More specifically, logical link control layer in data link layer. This is very equivalent to it. Okay. Another layer are your baseband link controller. Another is your link manager protocol, and one is your radio. Okay, so I'll tell you about it. Okay, another, this is RF communication. These are what are you seeing here? These are all the protocols that helps in communication. Okay, so I'll not discuss each and every protocol in detail. You can look for it. So these are just basic protocol that will be used for communication in Bluetooth. Okay, so another one is your application layer. So application layer is all we all know that it is used for user convenience, and whatever if the user wants to interact with the Bluetooth layers, so it can interact with via this particular layer. Okay, so these are all the protocols that a user can interact. Okay, so I'll tell you one by one. Okay, so radio layer. Okay, so this is the smallest layer that you see. Why it is it is also referred to as your physical layer. Okay, so because it is at the bottom one, so it is also acting as a physical layer. Why it is called a radio layer? Because your Bluetooth signals are also referred to as radio signals. Okay, so uh, they are following the same range that our radio signals have been. Okay, so now it performs modulation and demodulation. So it is the modulation and demodulation, you may have known about it. So if you not, don't worry about it, I will discuss about in modem and other architectures. Okay, so modem is again modulator and demodulator. Okay, so again modulation and demodulation is nothing that I will tell you when I come to it. Okay, so it performs modulation and demodulation of the data into RF signals. RF is your radio frequency signals or radio signals. It defines physical characteristic of the Bluetooth receiver. It defines two physical layers, that is connectionless and connection oriented. Okay, so again keep in mind that what is the meaning of connectionless and connection oriented here. So it does not mean that they will establish a physical connection by taking a wire. If there is a meaning of connection oriented, it does not mean that you will take a physical wire and then you establish a connection. And connectionless does not mean that yeah, it is just keep in mind that do not confuse this with wireless. Okay, so actually what is the meaning of connectionless and connection oriented? So when you establish a connection before transmission, okay, so when you establish a connection before transmission, it is referred to as a connection oriented. And when you do not establish any connection, you just directly send the data with a header. Okay, so the data will find its way towards the receiver here, so that there is no need to establish a connection beforehand. So that particular thing is referred to as your connectionless. Okay, so it does not mean Wi-Fi signal. So don't refer to connectionless as a Wi-Fi. Okay, so again, Bluetooth can be followed in these two approaches. First is your connection oriented, so it can act as both. Okay, so if you heard about switching here, so if you refer to the method of circuit switching, actually circuit switching is a connection oriented, because you have to establish a connection before you are transferring anything. But in packet switching, you may have seen that there is no connection that you have to establish beforehand. You only send the data. The data will find its way based on the information that is given in the header. Okay, so that is why packet switching is most probably referred to as a connection less protocol. Again, if you see, there is another the type of a packet switching, that is, I think, if there are type, there was data and there was virtual connection, virtual packet switching. So in that technique, what is happened there, so you have to, again, you have to establish a connection before. So the subtype is also connection oriented technique of packet switching. Okay, so again, you can refer to that lecture, I think, for connectionless and connection oriented. So it's very important, because these terms are used in many in any books. If you take in any books, they will be used extensively. Okay, so don't confuse these terms with Wi-Fi or wire. Okay, another link is your baseband link layer. Okay, so baseband link layer is your second layer. So it just this particular layer helps you to perform the connection establishment with a within a Piconet. Okay, so it means that if you this is a Piconet and this is your primary device, this is your secondary device. So this particular layer will help you establish the connection between a primary and a secondary layer. Okay, so again, keep in mind this the connection between secondary and secondary does not exist. The connection will always be between primary and a secondary. Okay, so another layer that is also on the top of it, that is link manager protocol layer. Okay, so it is just for management purposes. So it performs management of already established links. So already there are established link within a Piconet. That means that there is a there will be a master and a slave that is already connected to it. So it will just take manage the connection, so it has to stay active. It also include authentication and encryption processes. Okay, so encryption and other, if you want your data to be secure, again, in many if you refer to any book, so this particular layer will be absent there. Okay, so because in the early days Bluetooth, we do not use authentication and encryption processes. We just stress more about establish a connection. Okay, so if you refer to frozen book, you will not find this particular link manager protocol layer, because it is the encryption and another authentication is extra, or what you say, extra thing that is provided for user convenience and for security purposes. Okay, so it was included after establishing basic control. Okay, so this is the most important layer, that is your logical link control and adaptation protocol layer. Okay, so it is also known as the heart of Bluetooth protocol control. So I also tell you what will happen in this particular layer if you because how this particular okay, so one thing I want to tell you in this baseband link control. Okay, so it says that it performs connection establishment within a Piconet, and this performs a connection establishment with the help of something called TDMA. Okay, so it is time division multiple access. Okay, so time division multiple access, this is one of the multiplexing techniques. So if you studied your self study topic, in multiplexing there are three types of multiplexing. I think frequency, time division, and one other. Okay, so again, time division multiplexing means that you will be given a specific amount of time that you can communicate with other. Okay, so I'll give you example what is the meaning of this in this particular case here. In baseband link layer I'm talking. So okay, so how is this baseband link layer establish the connection? It is it establish the connection by using a TDM. Okay, so keep in mind Bluetooth also uses this technology, that is Bluetooth refer to this technology. I'll show you, it will make complete sense why I am telling you about this. Okay, so if it it occurs in two communication modes. The first mode is single secondary communication, single secondary communication, single secondary communication. Okay, so another mode is multiple secondary communication. So I'll tell you what single secondary communication is. Very simple. So what you do, they divide the time, in these particular slots. Okay, so I'm just talking these slots. Okay, so first these slots are for the primary, and if I'm talking about single secondary, because I'm saying that there in a Piconet there is only one primary connection exists, and then one secondary connection, and they are connected to each other. So this is the scenario when I'm talking about single secondary connection. So for secondary there is only one secondary here. So again the slot length will be same. Okay, so whatever is the slot length for primary, it will be the slot length for the secondary. Keep in mind, actually it is fixed to 625 milliseconds. Okay, so keep in mind the slot length is already fixed in Bluetooth communication to 6 to 5 milliseconds. Okay, so one other thing is suppose I divide. So if I start with this 0 slot number, 1 slot number, 2, 3, so just take 4, 5, 6. So I'm just taking 4, 5, 6. Just wait for a second. 4, 5, 6. Okay, so now how does it function is that the slot is already divided. The primary takes the even number slot, and the secondary take the odd number slot. So what is the meaning of it? That when you want to transfer some data, when you want to transfer some data, the primary will take this slot. Okay, so if you are taking this slot, this particular slot will be suppose if you are transmitted something that taken some amount of time. Okay, so this is the data that you have transferred. Now what it will do, when it is transferred here, the secondary will respond in the even number, odd numbered time slots. Okay, so now you have transferred some data, so this secondary will respond in this particular station that I have received the data or acknowledgement or anything, and it will send it to the primary station again. Okay, so if again the primary has something to send, it will again send the data, and it will pass this data towards the secondary, and again this particular, if it is responding, it will only respond in the odd numbered part. Okay, so that is how your TDMA work in when there is only single secondary connection communication, single secondary connection or a communication. Okay, so but when there are more connections, so in a Piconet, suppose in a Piconet there are two secondary devices. Okay, so how this TDMA will take place? This is your primary, this is your secondary connection. So now again it is divided into the same thing. Okay, so I'll just take it. So this is my primary connection, 1, 2, 3, 4, 5. So just take it. 0, 1, 2, 3, 4, 5, something like this. Okay, so there will be your primary, there will be a secondary 1, this will be your secondary 2. Okay, so this will again be divided into the same length slot. What was the slot? I think it was 6 to 5 milliseconds. Okay, so keep in mind. Okay, so now what happens is that when this primary is communicating some data, so what will happen? Suppose it communicates this data to this secondary. So it will this particular secondary station will respond directly because it's the first station, so it can respond in the odd number here. Okay, so the primary is sending the data to the secondary station 1, and there are secondary station 2. First time the primary is sending some data to station 1. Now this will again respond in the uh, odd numbered part here, so it will again directly respond to this one. The next time the primary is sending some data to the secondary part, so again, and the even number slot, it will send the data to the station 2. Okay, so again the station 2 will respond in the same odd number slot. Okay, so that is how it works. Okay, so again keep in mind that most of the time it will be a one-to-one. So when a primary station is sending some communication, some sort of communication to any of the link, it will directly send it, but it will send it on a odd numbered clock. Okay, so keep in mind. So every secondary station will follow a odd numbered uh, slot here. Okay, so that is why your again this particular communication method is referred to as multiple secondary communication. Okay, so every Piconet follows this multiple secondary communication. Okay, so this particular communication happens in baseband layer. Okay, keep in mind baseband layer. Okay, so now coming back to it, another was your logical link control. So all the things that we have already know about the data link layer, more specifically the logical link LLC. There are two layers. The data link layer is divided into two parts. First one is your LLC, and second was your MAC. Okay, media access sublayer, and LLC is your logical link control. Okay, so it is more similar to your logical link control layer. Okay, so it is known as the heart of the Bluetooth protocol stack. It allows communication between the upper and the lower part of the Bluetooth protocol. It packages the data received from the upper layer into the expected by the lower layer. Okay, so there's one thing here. There is one thing that is added here, that is your segmentation. Okay, so again the segmentation actually happens in transport layer, but there is no transport layer in this particular architecture. That is a different architecture, that is a Bluetooth architecture. So segmentation in this particular the segmentation process is given to this LLC layer here in this particular Bluetooth case. Okay, so don't confuse this, because every architecture is following a different thing, but actually they are following the same thing, but they are given in different layers. Okay, so what do I mean by this is that actually the transport layer has the functionality to perform something called a segmentation. Okay, so the network layer has something to do with your packetization, and data link layer has something to do with your framing. Okay, so every particular term in a OSI reference model is given like this. Okay, so what is the meaning of segmentation? That you divide the bigger packet into smaller packet. Okay, so again in every layer, if you are seeing here in OSI model, they will divide the packet into smaller packet, but the process is referred to as a different thing. Okay, so here the performs the segmentation here means that it will again divide the bigger packet of communication into smaller packet. Okay, so it just basically means that here. Okay, so don't confuse it with the architecture that you have already studied. So it is a completely different one. Here the segmentation actually means that it just divides the data into two parts. Okay, so again, if you're seeing here, it is why it is called the heart of it, because it is at the center of it. Okay, so it can interact with the user part as well. It can interact with the lower part as well, that is your totally based on the communication, that is ones and zeros. Okay, so it can understand the user query as well, and it can understand that how actually the below layers are working. Okay, uh, okay, so this is another thing, that is your ARCA. This is your, I think these are your protocols. Okay, so these are TCS, OVAX, WAP, and SDP. So WAP, I think you may have already heard about it. If you are, I don't think you may have heard about, because it was in the early 2004 and 5 that there was something called edge network. Okay, so edge network was, the connection was very slow. So that time we used to call that particular mode of communication as WAP. Okay, so again, it is short for wireless access protocol. It is used for internet access. Okay, so WAP is also present. Why it this particular protocol is present in Bluetooth? If I think you are not from that time, but what happens is that when Android devices came very new, there is something called Bluetooth tethering. Okay, so what happens with that specific protocol, that we are able to transfer our internet connection that was on edge to your I think to your any device which contains a Bluetooth. Okay, so if I have a working internet connection at that time, we used to do something called Bluetooth tethering. With the help of Bluetooth tethering, we are able to transfer our mobile's Wi-Fi connection, mobile's internet connection to other mobile devices which do not have any internet connection. But again, because it was a edge internet connection, so the speed was very low. Actually, the actual speed was very low. So when you're using a Bluetooth, it was also very slow. Okay, so it was again a very early device. But nowadays, I think if you use Bluetooth tethering, the internet speed is much higher. Okay, so again, another protocol is called Sdp Layer here. This is service discovery protocol. So all the protocols are written here, so you can just look for it and see what actually they do. Okay, so application layer, you already know, it is for the user convenience. Another is TCS, telephony control protocol. So this also provide telephone services. Okay, so again, keep in mind that these are the protocol that are present. Okay, so for every they are just what do you say, that if you're not using for Bluetooth, that the specific protocol will not get active. Okay, so suppose you are not using your Bluetooth for telephony control protocol or telephone services, that TCS protocol will not get activated. Okay, so most of the time you will not see that you are using telephone service via Bluetooth. Okay, so that does not happen. So again, there are many features that are attached to Bluetooth, but we use Bluetooth for only one or two or three features. Okay, so first feature is just to transfer some data, and the second feature is that you want to transfer some connection, or like by your internet connection to other devices. Okay, so again, there are many functions that are there that exist in Bluetooth, but actually we do not employ it. Okay, so again, what are the advantages of it? Again, you know that Bluetooth is one of the cheapest technology that you can find, that you can take like in 50 or 100 rupees you can get a Bluetooth. Okay, so another one is your easy to use. It penetrates through wall. It creates ad hoc connection immediately without any wire. It is used for voice and data transfer. Okay, so it can also happen that your Bluetooth can act as a walkie-talkie. So there was app in Android that used Bluetooth to for like 100 or 200 meters, it will act as a walkie-talkie. Okay, so disadvantages, it can be hacked, because I already told you that that this particular thing, that this layer, actually link manager protocol layer, it was not a part of the original layer. So the encryption and authentication protocols were not used, so that is why it is not considered as very secure. Okay, so again, this is an optional layer. Some Bluetooth architecture does not use this link manager protocol control, but I depicted this so that you see all the possible architecture of Bluetooth. Okay, so another one, it has a slow speed and it has a small range. Okay, so that is your Bluetooth, and I think it is fine for I covered the architecture here. So again, if you want, you can cover other things. You can refer to the book. So in book there is a quite a bit of detail of regarding Bluetooth. Okay, so because I think that you may give more preference to your more asked questions that is based on Ethernet or Ethernet 802 point. I think it was Ethernet token ring and Ethernet. What was it? I think 802.3 and 802.4. Okay, 802.3, 802.3 and 802.5. Okay, so that they are more important. Okay, another thing is your this is your I think last topic. This is one topic, that is Fddi. So it is just nothing. I will upload the PPT. You can just read about it. So it's very simple. It is fiber distributed data interface. Okay, so you can look about it. It's not a big topic. So just written a frame here. In this frame, all the things we have already heard about, that is preamble, start of the frame delimiter, frame control. We have already done this, all the all the part of the frame architecture. Okay, so you can just refer to this, that what actually is this, what actually the part of any frame is of how much bytes. Okay, so this preamble is 1 byte here, because if you remember, the preamble in Ethernet was, I think, 6 bytes, or something like this. Okay, 6 or 7 bytes, 5, 6 bytes. Okay, so that in that way only it differs, but all the things that you have seen here, it probably will be the same. Okay, so I will not repeat anything, because all the things I have completely covered in detail. Okay, so here, instead of using CRC in this FDDI frame, we use checksum. Okay, so checksum we have also done, so it is of 4 bytes. Okay, so when you are doing these topics, that IEEE standard, you always keep it to the frame. Okay, so when you remember the frame, all the functions will be very clear to you. Another thing, you also have to remember that how many bytes a particular part of the frame uh, occupies. Okay, so suppose a preamble in this particular case only occupies 1 byte of data, but the preamble in Ethernet occupies, I think, 5 to 6 bytes of data. Okay, so keep that in mind. Okay, so I'll upload the PPT, you can look for it. It's very simple. Okay, so the only thing that is remaining is the last topic of your is ATM, that is asynchronous transfer mode. Okay, so I'll discuss this topic in the next lecture with some uh, along with it, I'll also discuss some numericals also. Okay, so that you may have a good idea that what is going to be a part of your coming midterm. Okay, so what I'll do, I'll based on